Okay, now the next type of limits we are going to work on are the type where I ask you to find the limit at the place where the rational function has a hole. Okay, so again, we do not have the graph to be able to look at. I'll show you what this looks like algebraically. So back to our notes. Whoops, that's not the notes. Back to our notes. I can zoom out. Okay, so whenever you're doing limits, the very first thing you want to try for every single problem is direct substitution. You're going to try to substitute that value straight into the function that you're given to you. Now, if you try direct substitution and you get something like 0 over 0. Well, 0 over 0 isn't really a number. It's an indeterminate form. So if you try direct substitution and you get 0 over 0, then that is telling you that we need to try another method. And that second method is called factor and cancel. So let's look at a couple of places where that's going to happen. So in part 2, here's a summary of what I just said. If when finding f of a you get 0 over 0, the limit of f of a may or may not exist. So what you're going to do is you're going to factor both the numerator and or the denominator, and then do any cancellations, and then go back to step 1. And again, step 1 is direct substitution. Okay, so example 2a. I'm going to try direct substitution first, because when you do these problems on your assignment, you're not going to know if you're going to be able to evaluate this limit with direct substitution or if you have to factor and cancel first. All of the examples are kind of mixed in together, and you're going to need to know when to do what. So let's try substituting in -2 first. So I substitute in -2. And the numerator and the denominator. -2 squared is 4. -2 times 2 is +4 minus 8 over -2 plus 2 is 0. Now 4 plus 4 minus 8 is 0 over 0, and 0 over 0 is not a number. So that means we need to do something else. So let's try factor and cancel. Okay, so I'm going to erase that because 0 over 0 is not my answer. Don't say this equals 0 over 0. That's not your answer. It's just work that you're doing to say, oh, that way didn't work. I'm going to have to try another method. Okay, so I'm going to rewrite this limit. When you rewrite the algebra, you have to bring down the limit every single time because you're not doing algebra, you're doing calculus. So bring down your limit notation. So I factor the numerator, factors into x and x, minus 4 plus 2 over x plus 2. And I see that there's an x plus 2 in the numerator and an x plus 2 in the denominator, so I can divide those out. And now this is equivalent to the limit as x approaches -2 of x minus 4. Now notice I've also brought down my limit notation. I'm not saying this is equal to x minus 4 because I'm not doing the algebra. I'm doing calculus. So calculus is the entire thing. Now I'm going to go back and try direct substitution. So now I'm going to try to substitute in that -2. And -2 minus 4 is -6. So my limit as x approaches -2 of that function is -6. So that is my answer. Okay, I'll do another example. Let's do example 2b. Let me switch colors. All right, find the limit as x approaches 0 of 5x cubed minus 5x over x squared plus x. If I try to substitute in 0, I put a 0 here, 0 there, 0 there, 0 there, I'm going to end up with 0 minus 0 over 0 plus 0, which is 0 over 0. So if I see 0 over 0, I'm going to try my factor and cancel method. and come up with rewrite this limit. So this is equal to the limit as x approaches 0. I can factor out a 5x from the numerator. That leaves me with x squared minus 1. If you factor out an x from the denominator, that's an x times x plus 1. And let's see, will anything divide out? Well, I can divide out these x's. And then I can also factor a little bit further because I see x squared minus 1 is a difference of squares. So I'll factor a little bit further the limit as x approaches 0. X squared minus 1 factors into x plus 1 times x minus 1 over x plus 1. And I can cancel or divide out that other binomial of x plus 1, which is just going to leave me with the limit as x approaches 0 of x minus 1. And when you substitute in the 0 for the x, you just get negative 1. So there you go. Now, before I stop this video, one thing I do want to point out, you're going to lose points if you don't do this every time. It's something all us calculus teachers are really, really particular about, and it's the fact that you're carrying down this limit notation. Let me get a more highlighter like color here. So this limit notation needs to be carried down every time you've got an algebra expression. So see here, I wrote a limit here and a limit there where I have the algebra expression. Carry that down every single time. You can stop writing limit the minute that you go into the direct substitution part. When you start substituting in, you don't have any algebra left, okay? So make sure you bring that limit part down every time. I'm going to remind you over and over, but that's what you're going to need to do.